All right. Okay, so really quick, to solve the natural log, first thing we're gonna do is try to condense. So when you think about this, you want to condense this down to one natural log on each side. Is your ideal situation, and also using your power property. So we want to use between our power property, quotient, and product property. So here, since it's plus, that's how we know that it's going to be product. Because I'm possibly an excuse for the rest of just take it today. It's really up to you. I'm going to use the power property. I'm making a video and you're talking to me. So natural log of 3x squared minus 3x plus 2. That was right. Minus I can math, y'all. Sometimes I can't, but I really can't. Make that a little prettier. 3x squared minus 5x plus 2 equals natural log of x squared. Okay? Now, when we're solving this, the natural log, we're going to just apply e. So you're going to use e. So e, and what does that do? It's going to cancel our natural logs. And now all we're left with is 3x squared minus 5x plus 2 equals x squared. In order to solve a quadratic, it must be equal to 0. So we're going to subtract x squared. And we're left with 2x squared minus 5x plus 2 equals 0. At this point, you are going to factor this out. So if you remember, it's kind of like our box factor. So you do it really quick. It's just reverse box. To me, the visual helps. So you have 2x squared and you have 2. And you want to know what two numbers go in this box that will multiply to give you 4x squared, but add to give you negative 5. So it multiplies to give you 4x squared, but adds to give you negative 5. So that would be a negative 4x and a negative 1x. Negative 4 plus negative 1 is negative 5. And negative 4 times negative 1x is going to be positive 4x squared. And now all you're doing is greatest common factor. So when you're trying to remember how to factor, sometimes visualizing it like this helps a little bit. If not, then you can factor by grouping the classic way. So here are your factors. So this becomes 2x minus 1 times x minus 2 equals 0. So that means x equals, our first answer is x equals 1/2. And our second answer is x equals, okay? So between these two, one of them has to be extraneous, meaning that when I substitute it in, that it's going to make a true statement. Well, right here, if I substitute x 1/2 in for x, it's going to end up being a negative. So a natural log of a negative doesn't exist because you're already in the positives, positive x's. So we end up with a negative, and that doesn't work. So we know that this is our x cannot equal that, and so it's our extraneous. And this is our real. All right. On this side, we have log base 3x plus log base 3x minus 8. Again, it's going to be product property. So we end up with log base 3 of x times x minus 8 equals 2. Okay. So after we do that, we're going to raise it to the third power. So I'm going to raise everything to the third power. And the reason why I'm raising everything to the third base 3, however you say it, base 3 is so that I can cancel out the log. Because if you have an exponential, and a log of the same base, they cancel each other out. So we're going to be left with x squared plus, not plus, minus 8x minus 8x equals 3 squared is 9. I'm going to, this is a quadratic, so subtract 9. And we're left with x squared minus 8x minus 9 equals 0. One multiplies to give me 9, but adds to give me negative 8, negative 9, but adds to give me negative 8. That would be x minus 9 times x plus 1. Therefore, x equals 9 and x equals negative 1. So one of these, again, is our extraneous solution. This is a negative 1. If I plug it in for x, I'm going to be taking the log of a negative, which is not possible. So this is my extraneous, and this is my real. All right. Okay. So now we're going to word problems is what we have left to solve. And we'll do that next.